Yes, now I start recording at the same time, and we are going to have a revision. This is the first revision, and next week we are going to have a second revision about regression and some other analysis hypothesis. I'm going to upload this online, and you don't need to record, so please don't. So I'm recording it, and I'm going to upload it. Okay? Yes. Okay, so the first question is about finding mean, mode, median, range, standard deviation, and variance here. Yes, we have these numbers. So let us find their mean, median, and mode. So here, or I can use the math magic. 1 minute. I'm going to find the suitable software for writing to you. Okay, so these are the numbers. We are going to work with these numbers now. Okay, so how many numbers are there here? There are, what is n? N is 10. I have 10 numbers here. What is the frequency of 5? How many 5 I have here? 2. How many 10 I have here? 6. How many 15 I have here? Okay, so what is sum of these numbers? Equals to, I have 2, 5, 2 multiplied by 5 plus, I have 6 multiplied by 10, and I have 2, 15. And that's 100. So in order to find average, what I have to take the total and divide n. Okay, divide by n. N is 10 and this is 10. So mean is 10. So mode. What is mode? Mode is the number which has highest frequency. Which number has highest frequency? 10. 10 has highest frequency. And what is mean? Mean, for finding mean, I have to arrange these numbers. So what I had here is that I have 2 5s, 1, 2, 5. I have 6 10s. And I have 2 15s. Okay? Now, if I go from here to here, 4 from here to here. Okay. Let's write it different. And I have 4 numbers here. Okay? 4 from here, 4 from here. So these numbers are in the middle now. In the middle. Okay? So median is 10 plus 10 divided by 2. And that's 10. Okay? So median is equal to 10. So what I have here, I have mean equals to median, and which is equal to mode. What this means? If 3 of them are equal, what we say here, they are, this distribution is, what can we say about this distribution? This is normal distribution. Okay, because these 3 numbers are equal here. Okay. So, in order to find variance and standard deviation, I have to subtract. Moment. Yes, these are the numbers. I have to subtract mean from this. So mean is 10. I have to subtract from each of these 10. I have to subtract 10 from each of these 10. And I have to subtract 10 from this one, 10 from this one, and 10 from this one, 10 from this one, 10 from this one, 10 from this one, okay? So this is subtract. So these are the numbers. In my distribution, I'm going to subtract 10. 10 is mean from each of these. And the resulting value is, I have here 5. I have here 5, and these are all 0. Okay? And I have here 5, 5, and 5. Okay? Now square these numbers. We are going to square these numbers. 25. I am taking absolute value. Okay? So if it is 5 minus 10 is minus 5, but I am always taking absolute value here. This is 25. This is 25. And I have 2 more 25 here when I square these numbers. So add these numbers. I add and I get 4 multiplied by 25. I have 100. So variance equals to is total over n minus 1, that's 9. Okay, square root of variance. What is it? Square root of variance is? What is it? Standard deviation. What is it? Yes, standard deviation. Deviation. And that's the square root of this number is 10 over 3. You can leave it here like that. Okay, so this is the first question here. Let's solve the second question. Now here I have some female and male, and I know their frequencies. I want to find their percentages. Okay? Here, please wear your mask. All of you, please wear your mask. So the total here is 80. Okay? So out of 80, I have 50 female. So out of okay. So out of 80, I have 60. What is the number out of 100? What is the number? So how can I find it? I have to multiply 100 multiplied by 60, and I have to divide by 80. Okay? And now here I can see that 600 over 8. I can simplify it more, 300 over 4. And now this is 175 over 2. And this is 60. What is this number? Wait. Now, is it now this number is 150, sorry. Over 2. Wait, let me check it. This is 600 over 8. This is 100 over 4. This is 150 over 2. Let us check it from the beginning. 600 over 8, yes. 300 over, divide by 2, okay. Divide by 2, okay. So this is 75. Is there anything wrong? So now let's calculate. So this is how we do cross multiplication. So if we have out of 80, 60 people, that was the answer 75. But let's find what is the answer out of 80 if it is 50. You see that out of 80, I have 50 female. And what is the number? So here I have 500 over 8. And this is 250 over 4. And I have here 125 over 2. And this is 62.5. Right? So if it is 50, it is like that. So if I have out of 80, the other number is, let's check it. Out of 80, I have 30 here. I have 30 here, 30 female, 30 male. So out of 80, if I have 30 male, okay, so what is the case? So 30, 20, I multiplied 30 by 100, okay, and I have to divide by 80. And here I will find that's 37.5. Why it is like that? Because if I subtract from 100 this number, I have 37.5. Are you okay with this calculation? Okay. 62.5, 37 over 5. So this is here 62.5 and this is 37.5. These are percentages. Now, this is 60. Out of 60, if I have 40. Let's do some more calculation. If I have, I'm going to clean this here. If I have out of 60, 40, what is it the number out of 100? I have to multiply these two and divide by 60. 100 multiplied by 40, divide by 60. And that's 400 divided by 6 here. Okay, and that's 200 divided by 3. Okay. And that's, you will find 60.666, it continues like that. Okay, and the other number, so this is 60.6, 66.66, and it continues like that. And now here, if the number out of 60 is 20, let's calculate it here. Out of 60, if the number is 20, what is out of 100? We are going to do the same calculation. We have to multiply by 100, multiply by 20, divide by 60, and I find here 32.33. Okay. Yes, 33.33. Okay. So here, this one. Now, this is another equation with Excel. You know that Excel is also a statistical program here. So here it wants to find total of physics marks. To find total of physics marks, we have to use a formula. Let's do it here. I have this here. Now, total of physics marks, I have to use this formula. Okay, physics is here. This is C2. If I want to find total, that's equals sum. You have to write equals sum, open brackets, and the starting point is C2 here. You can see the starting point, and the ending point here is, this is C15. That's the ending point. And you close the brackets. Okay, C2, C15. This is the starting point, and 15 is the last number here. Okay, this is physics marks. Now, average of physics marks. To find average of physics marks, here we just change from the formula. Instead of sum, we have average. Okay, so what you have to know here is that in Excel, we always have equal signs for finding average and how to write these formulas. And you have to know that what is important is the starting point and the ending point. We have a starting point here of physics marks. This is C2, and ending point is C5. C15, sorry, C15. Okay, now this question. Minimum of biology marks. Let's continue from here. Biology marks is here, okay? So for finding minimum, we use this formula, equal sign, mean, okay? I open the brackets and I write E2. Here, this is E2, and the ending point is E15. Okay, so that's finding minimum of biology marks. Any questions until here? Okay, let's continue. By the way, I am solving the questions and I am recording at the same time. I upload these questions to Classroom and Uzem. Okay, you can find there, and I'm going to upload this video because I'm recording at the end of the course to YouTube channel. Okay, and you will be able to follow from there. Yes, okay, so find maximum of mathematics marks, maths marks. Let's find maximum of maths marks. Who is going to tell me this is maths marks? What I have to write here? Max. For that, equal. Max. Equal max, and I have to write B2 until the last point. B15, that's good. Okay, this is maximum of, sorry. Yes, B15, B2, B15, like this. Okay, so here, average of mark of student 1. This is a little bit different. So this is student 1. This is student 1, okay. Now here, this is it. This is student 1. And we want to find average of this marks here. So for that, I have to take this row. These are marks of this student 1. Okay, here I have equal sign. And since I want to find average, I write average. I open the brackets and I start from here. This is B2 until E2. B2, 2 dots, B, it's E2, okay? So I just take the row for finding average marks of student 1. And here, mean mark of student 2. For that, I have to use, this is student 2, and here for finding, for finding mean of this student 2, by formula, I have to write equal mean, and student 2 starts from this B2, wait, yes, B3, thank you, B3, and here E3, yes, okay. When I click there, it automatically writes here, by the way, and it's not important whether you write it in capital letters or small letters, okay, they all work. Okay, so let's continue. No, this is something Turkish. Okay, so maximum mark of students 4. Where is students 4? Student 4 is here. This is student 4. I want to find maximum mark equal max. Okay, I open the brackets. So student 4 is from B5 until E5. Yes, that's good. Okay. Okay, this is for student 4. Yes, average marks of student 9. Let's find that. Student 9 is here. So I want to find average of these numbers. How can I find that? I have to have always equal sign. If I don't have an equal sign, any Excel form do not work. That's the important thing here. And I have to write average. Okay, I open the brackets and starting from B10 and it ends until E10. Yes, that's it. E10 until E10. Okay. Yes. So find average mark of maths. Okay, let's find average mark of maths. So for mathematics, how can I find average mark of mathematics? Who's going to tell me? Yes? Equal sign. Average. Then open brackets. B2, 2 dot, B15. Yes, that's it. But it's important to write this equal sign, otherwise no Excel formula will work. If you don't write average, it doesn't calculate average. If you don't open brackets, so each item here is important. Bracket, 2 dots, okay, for having the answer. And you can see here that I write the formula and I have the answer. No. I have to close this one. Yes. 1 minute. Okay, so mean of chemistry marks. Let's find it. Where is chemistry marks? Chemistry is here. So how can I find mean of chemistry marks? Who is going to tell me? But before that, equal, mean, yes, bracket, yes, 2 dots, D15, close brackets. Okay, that's how I find minimum of chemistry marks. Now, average mark of students 15. Let's find average mark of students 15. So where is it? So, I don't have students 15 here. Okay, so this question, I don't have students 15. Let us make it students 5, okay? Student 5. So let us find average mark of student 5. How can you find average mark of student 5? Who's going to tell me? Equal, wait. I have to close this one. Delete. Yes, equal, average. B, is it 5 or B6? B6. E6, okay, that's it, yes. By the way, when we read these cells, for example, this here, this cell is C4. You read these numbers here, okay? This is C4. How you read this cell here? This is E, and this is 7. You can see E7 here, but you read it like that, E, and the number at the beginning, 7. Okay, so let's continue. Find average mark of all courses of all students. How I can find average mark of all courses of students? For that, I have to start from the beginning. This is B2, and until here, this is B15. So I have to write equal average. I want to find all the marks average. So this is the starting point always, and the ending point. This is E15. Look here. When I write it, it selects all the data here. Okay? See it again? Now, here I start from this dot, this cell here, this is B2. And if I write, for example, whatever I write, it selects. If I write B5, it selects B5. If I write E15, it selects 15, all the 15, all the data in here. So that's what I want. All the data, so that's it. From the corner here, this left corner, and this is the bottom right corner. I give the starting point and the ending point, and I click enter, and I can find the average from this formula here. Any questions here? Okay. So let's continue. This is Excel questions. Now here, what is nominal, ordinal, and scale? Who's going to tell me what is nominal? And what is ordinal? No one? They are group variables, okay? Nominal is the variables where the order is not important, and ordinal, the order is important. For example, for nominal, we have sex, and we have school, for example, female or male. Does not have any priority, or the school, for example, this school here, Cyprus Health and Sciences University and or nearest university does not have any priority. Ordinal, maybe education level has priority. Okay, if you are primary school or if you are listed student, that's important. And scale is just measurements, maybe weight, height, these are scale. 3 examples to statistical programs that is used. Yes, who's going to tell me? Excel, we have just used a statistical program. That's Excel, Microsoft Excel. And we have Spss here. That's another statistical program. Okay? We have Lizard, we have Stata, we have MATLAB. These are all statistical programs. Okay? We can do statistics. We can have descriptive statistics and analysis with these programs. Yes. What is the importance of having normal distribution? Yes? Normal distribution? Yes, that's good, thank you. When mean, median, mode is equal, we have normal distribution. But importance of it is that we can have when a distribution is normal and it satisfies the necessary conditions, we can have parametric tests, more reliable test. Okay, this is a Spss program. You can see it here. Okay, so here we have what tests are delivered via statistical programs? We have descriptive statistics and analysis. Descriptive statistics is the statistics that we have been doing. Frequencies, we have frequencies, we have percentages, mean, median, mode, standard deviation. These are for describing your data. Charts, okay, these are descriptive statistics. Analysis is when we have hypotheses and when we try to find whether there is a significant difference, the relations, the correlations between variables, these are analyses. These are more complex analyses, okay? So we have mainly two different types of statistics. Descriptive statistics for describing our data. These days, we have many descriptive statistics about COVID-19. It's saying that, okay, in Yrd, we have 200 cases today. In Nicosia, we have 150, for example. These are descriptive statistics. They are saying frequencies, the number of people. Okay? These are describing data. They are not doing any analysis. They are not saying that, okay, there is a significant difference between the patients who are in Yrd and the patients who are in Nicosia. So when one considers the amount of time that they spend at hospital, for example, like this, okay, this is just an example. So they are not saying that there is a significant difference, there is a correlation, there is a positive relation. These are analyses, okay? They are not analyzing. They are just describing what is the case. Okay, so statistics. Statistics is a science which deals with frequencies and numbers, percentages, graphs, and they describe the data and they can do analysis. This is a special part of science which has some math in it. And biostatistics deals with the biology. The examples are these with health science. Yes. Okay. By the way, this will not be included. I uploaded it, but I'm going to delete it from there. So this is equation of finding percentage. It says 45 students in a class, 5 French, 10 English, and the rest are Turkish. Find the percentage of Turkish students in this class. So the frequencies are given here. Let's calculate it here. So we have 45 students in this class, 5 French, and I have 10 English, and I have, yes, rest are Turkish. So how many Turkish? 30 Turkish. Okay, the rest, 15 minus 45 minus 15 is Turkish students. Okay, so what is the percentage of Turkish students in class? How can I calculate it? Who is going to tell me? How can I calculate it? Excuse me? So out of 45, I have 30 Turkish students. Out of 100, what is it? So 100 multiplied by 30, divided by 45, right? And what is the answer? So 100 multiplied by, here I have 15 and 15 here, 2 times, okay, and divide by 3. This is 200 divided by 3. And you can see here that 66.66. Okay? So this is the percentage. Okay, so what are parametric tests? Give 3 examples. Yes, we have t-test, okay? We have ANOVA. And here, t-test, we can have 1 sample t-test. We have pair sample t-test. We have to know just the names. These are for complex analysis, which we are going to study in Biostatistics 2. For this course, names are enough. Independent sample t-test. These are parametric tests. These are powerful tests. And when you see these tests, okay, then you can say that, yes, they did something good. And if they did the test correct, then their results are more reliable. So non-parametric tests, we have binomial tests. These are not all, by the way. These are just examples. Binomial tests, Kruskal-Wallis tests. We have Mann-Whitney test. Okay, and we have many other tests here. Yes, what is the difference of parametric tests and non-parametric tests? Parametric tests are more reliable. Non-parametric tests are less reliable. Okay, then why we deliver non-parametric tests if they are not reliable? Okay? If they are not reliable, because we don't have many people in our sample. For example, if we have patients less than 30, okay, it's a different case that we cannot find any more people to include in our study. Then, let us say, if we have 20 people, 15 people less than 30, then we can say that, okay, we cannot deliver a powerful test. For a powerful test, we have to have more than 30, okay? So each group should be more than 30. If we have, let us say, 3 groups, 3 different groups from 3 different universities, okay? Let us say from our university we have 200 people. From a university B, we should have, again, similar number. For example, if we have from one university 200, the other university 30, the other university 150, it's not also acceptable. We have to have group sizes similar, 1 or 2 less or 3 more is acceptable, but there cannot be big differences between the groups. We have to select our sample in such a way that we have similar number of participants from each different group. And these groups should be bigger than 30. Each group should be bigger than 30 for having parametric tests, for having more reliable tests. And parametric tests work with mean, which is more accurate. Non-parametric tests work with median. When we don't have a normal distribution, when the distribution is not normal, we use non-parametric test. When our distribution is normal, or when we can exclude some samples which is distinct cases. For example, let us say that we have a sample of students between the ages of 20 and 30, and we have and this sample is 200, and we have 2 students at the age of 50. Okay, So they may have different results. That's why that sometimes, if necessary, we can exclude them because they are less. Two students at the age of 15, we can exclude them, and we can continue with our sample of 20 and 30, the ages from 20 to 30. Okay, so this is what is done in biostatistics and the sampling. So we try to have, for example, with the patients, if we have one patient which has high cholesterol, okay, and the other patients don't have this problem, then we have to exclude that. We have to consider this patient as a special case if the other patients do not have same problem. And when we think about we are going to become dentists in future, and when you think about your patients coming to your clinic, maybe that if you have a patient of having high dentist fear, has psychological problems, and the other patients are normal, they don't get panic. For example, let us say you have 100 patients that you can include to your study, and they are the normal case, and that one patient should need special attention. So you can have this patient as a special test. So you can exclude it from the study, and you can work with the others for having a more reliable result. Or maybe that's 100 patients do not have allergic cases, and 2 patients has allergic cases. You can exclude them, and the medicines that you can give to them should be different. Okay, so you should have in your sample the patients which have similar properties, similar health background. If they are not similar, psychological or physically, you cannot have them in your group. If you have them in your group, then you cannot have parametric tests. You should apply non-parametric test.